Hi folks, this is Michael Matthews, and I'm going to share a little bit about a modeling project I did for a rotating ball that lands on the ground and bounces. Here I am with my basketball. If any of you all play, you've seen people step up to the free throw line and throw the ball forward with a little backspin. Instead of bouncing forward, the ball bounces back to them. I was curious to see how that happens, and I wondered if I could create a model to simulate it. We're in a software program called Tracker. This is a slow-mo video I made. You can see a little dot in the middle. That's the point mass for the center of the ball. And then a dot out here that's orange is going to track the rotations. Tracker lets you put in a coordinate axes and a scale. That's the width of the basketball. And when we play it, you can see that the tracker has matched or tracked the data. Here it is spinning, headed forward, and when it bounces, it's going to come back to me. Notice that it's not spinning as much here, right? So here's the data extracted through Tracker and then plotted in Python. You can see the center of the mass and the rotation. And so here's the Python code that I wrote, or part of it, the model trajectory function. And you can see it's got the mass of the ball and the radius and the inertial mass. And the key here was figuring out how to deal with what happens during the collision. So the impulse formula is going to be right here for part of it. So it's not a perfect model right now. Let's take a look at it in the model trajectory and see how it works. Doesn't match just right, but pretty close. So you can see in blue is the center of mass, the green is the model of the rotation, and they're tracking pretty well. After the collision, however, things start to diverge a little bit. In general, my model did not apply enough impulse during the collision across all my different experiments, and I'm not exactly sure why. That's something that I still need to study a little bit more. But either way, I've been pleased with the simulation and the animation and figuring out the rotations and all that. So it was a fun project. Thanks for listening.